In this video, we're going to do optimization questions involving exponential functions. So, in the first example, the effectiveness of studying for an exam depends upon how many hours a student studies. And some experiments have shown that if the effectiveness is put on a scale from 0 to 10, then the effectiveness as a function of time, where time is measured in hours, will equal 0.5 times the quantity 10 plus t e to the negative t over 20. What's kind of interesting about this is, as we'll see, the largest number of hours spent won't necessarily be the most effective way to study. But in this case, we're told a student has up to 30 hours to study, so we want to determine how many hours will provide maximum effectiveness. So what we're going to do, given this function, is first of all, we can distribute that 0.5, and we'll get 5 plus 0.5 te to the exponent negative t over 20. We'll re-express negative t over 20 as negative 1/20th t. So this quantity that you see circled here is actually in the exponent. Now, what we're going to do is differentiate this expression and set it equal to 0. So the derivative of 5 is 0. But then we're going to determine the derivative of 0.5t times e to the exponent negative 1 over 20t. And to do that, we're going to use the product rule. So this is the expression 0.5t and then e to the exponent negative 1 over 20t. That's what we're about to differentiate. So we'll determine the derivative of the first and multiply it by the second. And so that gives us our 0.5 e to the negative 1 over 20t. And then we will add that to the first times derivative of the second. So the derivative of e to the negative 1 over 20t is e to the negative 1 over 20t times the ln of the base, so ln of e, times the derivative of the exponent, which in this case is negative 1/20th. So the ln of e is just equal to 1, so that kind of cancels itself out. So this negative in front that I'm circling right here on the 1/20th is going to multiply with that positive and become a negative. And so we're just going to have 0.5 and then 1/20th and then te to the negative 1 over 20t. So it got kind of messy, but that is the expression we get. And then we're going to see that what we have is an opportunity to actually factor out 0.5 e to the negative 1 over 20t. If we factor that out of the first part, we're left with 1. If we factor that out of the second part, the 0.5 and then e to the negative 1 over 20t, what we're left with is, in fact, 1 over 20t. So common factoring gives us this, and hopefully that's kind of clear to you. So what we're saying is that when we set that derivative equal to 0, we're saying that 0 will be equal to that expression next to the arrow. So that means that either this first factor is equal to 0, which we wrote here, or this second factor is equal to 0, which we wrote here. Well, let's focus on the first factor. If 0.5 e to the negative 1 over 20t is equal to 0, then dividing both sides by 0.5 tells us that 0 is e to the negative 1 over 20t. So that would mean that negative 1 over 20t, the exponent, must be equal to the log base e of 0, or in other words, the ln of 0. But the ln of 0 doesn't exist. So this factor equaling 0 is an impossibility, and it leads us nowhere. So let's take a look at this second factor. That factor might equal 0. So if 1 minus 1 over 20t is equal to 0, then that means negative 1/20th t is equal to negative 1. Dividing both sides by negative 1/20th, we get t is equal to 20. So t equaling 20 is a possibility. That the derivative equals 0. And if you recall, our domain was 0 to 30 because we were told the student had 30 hours to study. So what we're going to do is plug in to the original effectiveness formula a t-value of 0, a t-value of 30, and a t-value of 20. So plugging into the original expression, letting t equal 0, we get an effectiveness level of 5. If we let t equal 20, we get an effectiveness level of approximately 8.68. And if we let t equal 30, we get an effectiveness level of approximately 8.35. And so what's interesting is that the most effective number of hours to study would be 20. Perhaps that would mean there's a little extra time for balance in their life and some sleep and nutrition, etc. Okay, a second question. We have a consultant that determines the proportion of people that have responded to an advertisement of a new product after it's been marketed for T days is given by this formula right here. So to help give an image to it, perhaps we're talking here about a billboard. And so a billboard's been up for a certain number of days, and we want to know the number of people who've responded to it, or in other words, the number of people maybe who've noticed it and registered it on a conscious level. Now, the area covered by that advertisement contains 10 million potential customers, and every time someone consciously recognizes it or responds to it in the wording of this question, there's an average revenue of 70 cents. Now, that's not profit, that's revenue. And we keep in mind the company wants to maximize their profit, but the costs include $30,000 to produce and $5,000 per day to run. What we're going to do first of all is determine the limit as t goes to infinity of this expression and interpret the meaning of that. Then we're going to determine what percent of customers have responded after 7 days. Well, that'll actually be fairly straightforward. It'll essentially just involve plugging 7 straight into the formula. Then we're going to determine a profit formula. What we were given was a percentage people who've responded formula. We'll come up with a profit formula. And finally, we know the company would like to maximize their profit. So we're going to figure out how many days they should run their ad campaign in order to accomplish that. So the first one is determining the limit as t goes to infinity of f of t. So that's like saying the limit as t goes to infinity of 0.7 times 1 minus e to the negative 0.2t. So we can distribute this 0.7 in here, and we get the limit as t goes to infinity of 0.7 minus 0.7 e to the negative 0.2t. Well, taking this e to the negative 0.2t and putting it in the denominator, we get the expression shown next to the most recent check mark there. Now, we can actually distribute this limit notation. So we're taking the limit of this whole expression. Let's take the limit of the as t goes to infinity of the 0.7 and then subtract from that the limit as t goes to infinity of the 0.7 over e to the 0.2t. And that's what we're showing here. Now, the limit as t goes to infinity of 0.7 is simply 0.7. The limit as t goes to infinity of 0.7 over e to the 0.2t is 0, because what's happening is as t goes to infinity, this exponent on e is going to become infinitely large. Now, e is equal to roughly 2.7. So we're going to be, our denominator will be essentially 2.7 to an unimaginably huge number. Well, that's going to be really big. And so 0.7 in the numerator will be dividing this huge number. So we can safely say that that limit is equal to 0. And that 0 is shown here. So this limit is equal to 0.7, and this limit is equal to 0. So when we get 0.7 minus 0, the answer is 0.7. And so as time goes to infinity, f of t goes to 0.7. Now, what does that mean? F of t represents the proportion of people who've responded, and therefore only 70% of people might ever respond to the ad. In other words, 30% will never respond. So let's say, for example, it's a billboard and a response just means a conscious recognition of the billboard, well, maybe 30% of people will never go to that part of town, or maybe they never are in cars, or who knows what. That's why you could leave it up forever and you're only going to reach 70%. That's what part A is saying. Now, for part B, this is a relatively straightforward question. All they're asking us to do here is let t equal 7 and plug it into the original expression. So f at 7 will equal 0.7 times 1 minus e to the exponent negative 0.2 times 7. And letting our calculator do the hard work, that's 0.527. So that's a proportion of customers who've responded. So 0.527 is like saying 52.7%. Now, what we want to do next is determine the average profit. Okay, so determine profit, we're going to determine revenue and cost. So to determine revenue, let's get the total number of responses. Well, F at T represents the percentage of people who've responded. Okay, so F at T represents that, the percentage of people who've responded. Well, if we multiply that by 10 million, because there are 10 million people there in the area of potentially affected, 10 million times F of T will give you the actual number of people who have responded. So again, F of T represents a proportion of people who've responded, 10 million people total. So multiply those two and you've got the total number of people who actually responded. And that is represented right here. This 0.70 in front, if you recall, the question told us every time someone responds, the average revenue is 70 cents. So that's what that 0.70 is. So 0.70 times the number of people who've responded, which is 10 million F of T, will give us our revenue. Okay, so 0.70 right here times 10 million right here is equal to this 7 million. And then F of T right here is equal to this. And so all we have to do now is distribute in this 7 million. We'll multiply it by the 0.7 and we'll get 4,900,000. And we'll still have this bracketed expression right here that we haven't yet multiplied by. And now we're going to take that 4,900,000 and we're going to distribute it into that bracket. And we're going to get this expression at the bottom. That's an expression representing revenue as a function of time. Now, that's not what the question wants. The question wants profit. So let's now determine our costs. Well, our costs include flat costs plus variable costs. So our flat cost given in the question is $30,000. This ad costs $30,000 upfront to produce. Now our variable cost, since it's $5,000 times the number of days, we have to figure that in as well. Well, the number of days is given by T. So our cost formula is simply 30,000 plus 5,000 T. Now we know profit always equals revenue minus cost. So it'll be 4,900,000 minus 4,900,000 e to the exponent negative 0.2 T. That's our revenue, minus this 30,000 plus 5,000 T, which is our cost. Distributing that minus sign into the bracket, of course, we get this quantity here, and collecting up our like terms, we have a 4,900,000, and we're subtracting a 30,000. What we get is this final equation down here representing profit. 4,870,000 minus 4,900,000 e to the exponent negative 0.2 T minus 5,000 T. Okay, well, what's the profit after 7 days? We just simply have to plug that straight in here. So we plug in a 7 for T, and we let our calculator do the heavy work, and we get $3,626,674.88. That's the profit after 7 days. Now, finally, we want to know how many full days should the advertising campaign be run to maximize profit. So what that means is we should figure out our domain. Now, the question tells us that the total cost must be under $200,000. So, because it tells us there's a budget of $200,000 to run this thing. So we know that the total cost of 30,000 plus 5,000 T must be less than or equal to 200,000. Well, subtracting 30,000 from both sides, we get 5,000 T must be less than or equal to 170,000. And then dividing both sides by 5,000, we get T must be less than or equal to 34. So we've got an upper limit on our domain of 34, and we have a lower limit on our domain of 0, because obviously it's possible to run this campaign for 0 days. Now, what we want to do, since we have our domain and our formula, we want to get the derivative of our profit formula. So the derivative of 4,870,000 is 0. The derivative of negative 4,900,000 e to the negative 0.2 t is negative 4,900,000 e to the negative 0.2 t times the ln of e, because that's the base of the exponent. We know the ln of e is 1, times the derivative of the exponent. Now the derivative of negative 0.2 t is negative 0.2. Finally, the derivative of negative 5,000 t will be negative 5,000. So now this negative here and this negative here multiply, they'll become positive. And running that multiplication through, we get 0 is going to equal a 9,800,000 980,000 e to the negative 0.2 t minus 5,000. That's what 0 equals. So we're just going to add 5,000 to both sides, and we'll be able to say 5,000 equals 980,000 e to the negative 0.2 t. So dividing both sides by 980,000, we get that negative 0.2 t ultimately will equal the ln of 5,000 over 980,000, because that fraction will equal e to the negative 0.2 t. And how do you bring that exponent down so you can solve for it? Since the base of the exponent is e, we use ln. Okay, so logarithms tells us that's the way to go. So negative 0.2t will roughly equal negative 5.278. So t will be roughly 26.4. So we're going to call that 26 days. 26 days falls within our domain of 0 to 34. So now we're going to determine the profit formula at 0 days, 26 days, and 34 days. Well, if we run the ad for 0 days, our profit will be negative 30,000, which makes sense. It took $30,000 to actually make the ad. So if we did all that work but then never ran it, we'd lose money, negative 30,000. If we run it for 26 days, we see that our profit will be equal to we'll see that our profit will be equal to $4,712,969. If we keep on running it for 34 days, we'll still make a nice profit, but it actually won't be as much. We'll get more in revenue, but we will it'll start costing us more and more money, and it won't be worth it ultimately to do that. So to maximize profit, the company should keep that ad up for 26 days.